Hi, welcome to 10 Tool Tips, how Ubisoft uses human biology to design better tools. I'm David Lightbound, User Experience Director for the UX team at Ubisoft Montreal. I've been working in the games industry for almost 20 years, and I've spent most of my career focused on game development tools, pipelines, and workflows. Before I begin, I'd like to thank the SETIC committee for inviting me to speak here today. I'd also like to thank Ubisoft for supporting my passion for game development tools. And finally, I'd like to thank you, the audience, for choosing to attend my presentation today. Today, I'd like to tell you to stop. I'd like to share with you 10 things that you should stop doing if you want to design game development tools that are better for your users. For each of those 10 things, I will also tell you what to do instead, as well as the human biology science that explains why you should. And we're going to see examples of how to do those things with this imaginary game development tool called the Ubi Editor. This presentation is divided up into 3 parts to cover the most important aspects of human biology as it relates to designing game development tools: visual, cognitive, and motor. First, let's talk about a few tips related to the visual aspects of human biology. Number 1. Stop putting basic controls in unexpected places. Instead, put controls where your users expect to find them. What do I mean by that? Well, I mean putting controls to open and save the file at the top left, or putting a search box at the top of a window, or putting controls to change the view at the bottom, and so on. Why is it important to put controls where your users expect to find them? To understand this, let's take a look at the human eye. The retina is the area on the inside back part of the eye. Light enters through the cornea and hits the retina, which is covered with light-sensitive cells called photoreceptors. This is part of what makes it possible for us to see. These photoreceptors are very dense in the center. This means that our central vision is small, but high resolution. However, as we move toward the outside of the retina, there are less and less photoreceptors. This means that our peripheral vision is large, but low resolution. To understand the size of your central vision, let's do an activity. Hold both of your hands out in front of you and look at your thumbs. Imagine a circle with the diameter the width of your 2 thumbnails together. That's approximately the size of your central vision, where your vision is the sharpest. That means that if we're sitting at arm's length from a computer screen, it's impossible to see everything on the screen in high resolution at once. We see parts of it as we move our eyes around. That means that if we don't know where to find something, we need to move our eyes around to find what we're looking for. How do we know where to put things where people will find them? Well, one of the easiest and most effective ways to do this is to look at where similar controls are placed in the software that your users already use. For example, controls to open and save a file are almost at the top left, almost always at the top left. Search box is often at the top right-hand corner of many tools. Controls to change the view are often at the bottom right. Let's take a look at an example in the Ubi editor. Let's imagine that a user is looking for an asset. They know the name of the asset, but it's at the bottom of the list, here being alphabetical. As you can see, the search box is in an unexpected place, at the bottom instead of at the top. The user's central vision is focused on the assets, so they only see a small part of the interface in high resolution. Because they are not accustomed to the search box being at the bottom, they don't notice it. So even though they could search for it, they think they need to scroll down the list to find what they're looking for, wasting time. But if we stop putting basic controls in unexpected places and instead put controls where your users expect to find them, then we know to put the search box at the top, where users are more likely to find it. Number 2, stop expecting users to notice small, subtle changes. Instead, use movement when you need to get the user's attention. What do I mean by this? I mean that if you need the user to notice a change in something that they're not already looking at, you need to use movement to get them to shift their central vision to that spot. Remember how earlier we spoke about how peripheral vision is low resolution because there are less photoreceptors on the outside edge of the retina? Let's do another activity to really understand what that means. Look at the circle with the number inside. Now I'm going to change the number. When I do that, I want you to hold up your hand and show me with your fingers what the new number is. Okay, good. That's right, it's 2. Now I'm going to make this number bounce. And I want you to show me with your fingers how many times it bounces. We would count 1 bounce as the circle going up and then coming back down. That's 1 bounce. Ready? And go. Okay, good. So 3, everybody agrees that that was 3 bounces? Okay. Now we're going to make this harder. I want everyone to turn their heads 90 degrees to one way or the other and keep your eyes straight ahead. Look at the wall, but do this so the screen is showing, the presentation is just in the outside corner or edge of your vision, so you can barely see it in the corner of your vision. Now I'm going to change the other number, and you can't move your eyes. You can't look directly at it. Okay, without moving your head or your eyes, is anyone able to show me what the new number is with your fingers? No, I didn't think so. Okay, now don't move your heads. Keep your heads turned with the presentation right at the corner of your vision. Okay, now I'm going to make this number bounce. And just like before, when it stops bouncing, I want you to show me with your fingers how many times it bounced. Ready? And go. Okay, now you can look back at the screen. Everyone agrees 2? Did you notice that even though you can't see which number changed in your peripheral vision, you can still tell how it moves? What does this tell us? Well, it tells us that even though our peripheral vision is lower resolution, it can still detect movement. Now consider the average game developer's desk. As we said before, a monitor is about an arm's length away from your face. But many of us don't have only one monitor. We might have 2 or 3, or a television connected to a console. If we consider that a circle with a diameter the width of your 2 thumbnails together is the high resolution of area of our eyes, think about how much of our other monitors are not in our central vision. So now imagine that there is a small icon on another monitor that indicates the number of warning messages. There is very little chance that someone will see that number change, unless they're already looking directly at it. Therefore, when it's important to get the user to notice something, using movement, like a grow and shrink or sliding animation, is usually enough to get people to shift their focus to that point of the screen. Now keep in mind it has to be large enough to be noticed, but it should also only repeat a few times so it's not irritating. Let's go back to the UB editor. Imagine that the user is trying to add a new asset into the level, but the editor won't let them and they can't figure out why. While adding the asset, this icon changed to show an error message telling the user that another user is working on that level and it has been locked. But because their central vision is focused over here, they don't notice the change. So if we follow this tip, stop expecting users to notice small, subtle changes and use movement when you need to get the user's attention, we can add movement to the icon so the user has a better chance of noticing it. Number 3, stop differentiating controls and icons by color only. Use both shape and color to help users tell controls and icons apart. What do I mean by that? I mean that instead of making controls and icons different by color only, use both shape and color to make them look different. To understand why this is important, let's learn a bit more about photoreceptors. Photoreceptors are divided into 2 categories: rods, which are very sensitive to light but cannot detect color, and cones, which are less sensitive to light and movement. However, they have a very special function. They can detect color. There are 3 types of cones, those that can detect red, green, and blue. If you look at the distribution of cones, you'll notice that red and green cones are more concentrated at the center, while blue cones are mixed in with red and green on the edges. However, not everybody's vision is perfect. Some people have difficulty detecting certain colors. You've probably heard of this referred to as color blindness. Let's do a quick activity before I explain this further. See if you can figure out the answer to this math question. I'll tell you the correct answer in a few minutes. Okay. If any of you had some difficulty with that, or you aren't 100% sure you saw the right numbers, don't feel bad. 1 in 12 men and 1 in 200 women in the world have some sort of color blindness. That adds up to around 300 million men and 20 million women in the world. And most importantly, many people who are colorblind are not even aware of it. The most common form of color blindness is a reduced sensitivity to green light that is generally not a problem. However, there are more extreme forms. The third most common type of color blindness is protanopia, where people cannot tell the difference between red and green because they do not have cones that detect red. So now imagine that one of your users is working with a list of similarly shaped icons that are only differentiated by color. If the only difference is that one is red and one is green, someone with color blindness could easily make mistakes. Also, color blindness isn't the only reason to do this. Consider that icons are sometimes disabled, which means that they'll be gray. Then it's even more important to have a unique shape as opposed to relying only on color. And finally, we also spoke about having multiple monitors. When we're developing a tool for someone else, we often look at it right in our main monitor using our central vision. But the reality is that people will sometimes be looking at your tool on a second monitor at an angle, potentially with reflections that change the colors. That's another reason why it's a good idea to use shape in addition to color. By the way, the answer to this was 13. Mocam is a tool developed at Ubisoft for facial capture and animation. Now you can see here that even though some of the icons are the same color, these icons can also be differentiated by shape. Let's see an example of this in the Ubi editor. There is a mode in this editor to edit zones. Red zones kill the player, and green zones win the level. However, if the user placing these zones has protanopia, the zones will look like this to them. Or if the zones are disabled, it could look like this. But if we follow the tip, stop differentiating controls and icons by color only, and use both shape and color to help users tell icons and controls apart, then we can use both shape and color and help users tell the zones apart, regardless of color blindness, the enabled state, or reflections. Number 4, stop assuming that what you see is what your users see. Talk to your users to learn how their brains interpret the interface. What do I mean by this? Well, since the beginning of this presentation, I've spoken about how our eyes have limitations. And there's one big limitation that we haven't spoken about yet. We learned that the retina is covered in photoreceptors. However, maybe you notice there's one spot where there are none. This is the spot where the optic nerve connects to the eye, carrying information to the brain. You've probably heard of it referred to as the blind spot. Because there are no photoreceptors in the blind spot, your brain has to fill in what's missing in that spot. Let's do a quick activity to understand this. Cover one eye with your hand. Now, is there a big empty spot in your vision right now? A big blank spot? Of course not. This is because your brain is tricking you and filling in the missing pixels with what it thinks is there. You can uncover your eye now. Let's do another activity to understand this more. What do you think comes next in this sequence? A letter or a number? Take a minute to decide. Some of you might think that this is a letter B, and so then the letter that comes next is C. But some of you might think that this is the number 13, and so then the number 14 comes next. So you can see how two people can see the exact same thing, but their brains can interpret it differently. But what if you did this? If you put the letter A first, people would be more likely to guess the letter C. And if you put the number 12 first, people would be most likely to guess the number 14. Now you can see how it's possible for people to see the same thing, but for their brains to interpret it differently. So stop assuming that what you see is what your users see. Talk to your users to learn how their brains interpret the interface. Now this is a good segue into our next section, which is about how the brain interprets what we see with our eyes. So let's see a few tips on the cognitive aspects of human biology. Earlier we spoke about how the optic nerve is connected to the retina, and that is the reason why we have a blind spot. The optic nerve carries information to the visual cortex, where it's processed and then interpreted by the rest of the brain. Which brings us to our next tip. Number 5. Stop inventing new icons for commands that already exist. Reuse existing icons that are already familiar to your users. What do I mean by that? I mean that you'll have much more success in getting your users to learn and remember what an icon means if you reuse icons that they already know, as opposed to trying to design what you think might be a better icon. Let's do another activity to understand what that means. What do you think this icon is for? Raise your hand if you guessed answer a call, phone call, call. However, when was the last time you used a rotary phone? But that shape on the top, that's where this icon comes from. So would this icon be better? It's more accurate, isn't it? But most people would still recognize the first one more quickly. Next, what do you think this icon is for? Okay, raise your hand if you thought battery or low battery. However, is this what our phone batteries look like? And can we see how full they are by cutting them in half and looking inside? Would this be a better icon for battery? Probably not. Finally, we all know what this icon means. But when was the last time you saved your work on a 3.5-inch diskette? But it doesn't matter. People know that it means save, and that's the most important thing. So why were those icons so easy to identify, even though they're not a perfect representation of how we do these things today? And it's because they exist in our long-term memory. These icons are not a perfect representation of the concept, but that doesn't matter. We know what they mean because we've learned them at some point, and they have remained in our long-term memory ever since. So people either know what the icon means or they don't. And if they don't, it's okay. You have to teach them, usually by providing text, which we'll talk about in the next tip. If your tool needs icons, start by researching the other tools your users may already be familiar with. If they use Excel, Maya, or Photoshop, and the button in your tool does the exact same thing, use the same icon or an icon with the same silhouette that matches your tool's colors. Creating a new icon not only takes more time, but it's actually worse for the users because they have to learn and remember it. The Ubisoft games of Far Cry, Watch Dogs, and The Crew all use an editor called Dunia. Most of the people who use Dunia are familiar with the icons in Autodesk 3ds Max. So many of the icons are directly inspired from 3ds Max, which gives the user a better chance of learning and remembering what they do. Let's look at an example of this from the Ubi editor. These icons might make sense to the developer who made this tool, but they don't make sense to the users because they are different from any other icons that they have seen before. But if we stop inventing new icons for commands that already exist and reuse existing icons that are already familiar to our users, then we have a better chance of the users recognizing the icons because they have seen them before and they already know them. Number 6. Stop using icons with no text, tooltips, or documentation. Provide a way for the user to learn and recall what each icon is for. Why do I recommend this? Well, what can we do if we need an icon for something that doesn't already exist in another tool? Well, the user has to learn it. We start to learn what happens when we press on a button in a variety of different ways. Text next to the icon, tooltips, or through the documentation. We need to learn how the interface works somehow, and adding text to the interface is one of the most cost-effective ways to do that. Susan Weidenbeck did a research study comparing 3 different approaches to helping people learn and remember what different buttons do. Text only, icon with text, and icon only. The best result came from a button with icon plus text. Next best was text only, and icon only scored the worst. There are a lot of tools that use the icon plus text approach. One of the reasons why software like Word, Excel, and PowerPoint do this is that some people are only occasional users. The use of icon plus text makes it easier for people to learn and remember what the buttons do, especially if they don't use them every day. But there are also some tools that have a lot of icons without text. The main advantage of this is that the icons use up less space in the interface. And this can be important in the case of an interface where the users want to see as much of their document as possible, like Photoshop or Maya. In this case, tooltips can be used to help people learn what an icon does. Some people might say, well, once people learn the icon, they'll remember it forever. Now, it would be nice if this was true, but it's not. We often talk about the process of people acquiring new knowledge as following the learning curve. But people forget what they have learned too, and so there is also a forgetting curve, demonstrated here by Hermann Ebbinghaus's research in 1885. Without constant reinforcement, people start to forget things within 10 minutes of learning them. And according to Mr. Ebbinghaus's research, people can forget half of what they've learned in as little as just 1 hour. If you learn a new language, but then don't speak it every day, you start to forget the words. And if there is nothing to help you refresh your knowledge of a tool, you will start to forget what you've learned as well. By having text labels, tooltips, and documentation, you help the user to refresh their knowledge of what the icon means. Let's look at an example in the UB editor. The worst way for the users to learn the icons is for them to click on each one and see what happens, especially if the result is not what they expected. This would make the tool feel more like a bad version of Minesweeper. But instead, if we stop using icons with no text, tooltips, or documentation, and instead provide a way for the user to learn and recall what each icon is for, here we have menus with icons plus text, tooltips for the icons without text, and access to the documentation. This way users can constantly learn and recall what each of the icons are for. Number 7, stop showing the same type of data in a different order. Instead, show data in the same order consistently so users see patterns. What do I mean by this? I mean that anytime you present data, ideally it should be presented in the same way, in the same order, with the same formatting. Why is this so important? Well, consistent patterns are necessary to learning anything, like a new language, for example. To learn a new language, you must first understand the sentence structure. That sentence structure needs to have a consistent pattern everywhere else. However, if the sentence structure is always different, learning is much more difficult. To help you understand further, let's do another activity. I'm going to show you a number of dots on the screen, and you will have 3 seconds to try to count as many of them as you can. Are you ready? And go. 3, 2, 1, okay. Now, how many dots do you think were on the screen? Raise your hand if your guess was less than 16 dots. Okay, how about 16 to 18? How about 19 to 21? Did anybody guess 22 to 24? And how about 25 or more? Okay, so now I'm going to show you the same number of dots again, but this time you're only going to have 2 seconds. Are you ready? And go. 1, 2, stop. Okay, now raise your hand if you guessed 20 dots. So why was that example so much easier? Well, it's because you all have hardwired that face on a 6-sided die to the value of 5 in your brain by playing board games. When you see it, you know that it's a 5 right away without counting, and you can do the math in your head to get the total number of 20. If things are consistent, it's a lot easier to establish patterns. But if they're inconsistent, it's harder. Imagine if the face of that die had a different configuration of dots each time. It would be just as frustrating as the sentence structure in a language changing. And it's the same for software. When we see the same pattern in an interface over and over again, we get faster at recognizing it, which means we can react to it more quickly. For example, when you're creating a new document, changing the image size or changing the canvas size, Photoshop and other Adobe applications always show you the size as width first and height second. However, within PowerPoint and other Microsoft applications, sometimes height is shown first, and other times width is shown first. Also notice that the unit of measurement is shown as double quotes everywhere except for here, where it's shown as the letters IN for inches. All of these things make it difficult for users to learn patterns when it comes to calculating the size of objects. Let's see an example of this problem in the UB editor. The asset panel shows us the size of the selected asset at the bottom as width first and height second. But the size of the selection in the level is shown as height first and width second. This makes it very confusing to compare the selection to assets in the asset panel. So what should we do? Well, we should stop showing the same type of data in a different order, and instead show data in the same order consistently so users see patterns. In this version of the UB editor, width is first and height is second. This makes it a lot easier for users to compare the sizes of assets and to make calculations in their heads about how they will fit. Number 8, stop counting the number of clicks. Instead, look at how much time is spent in between clicks. What do I mean by that? Well, instead of counting how many clicks it takes to do something, we should be counting how difficult each click is. In other words, how long it takes to get to the next click. Some people think that the number of clicks is a way to measure how efficient an interface is to use. The reality is that 4 fast clicks could take the same amount of time as 1 slow click. For example, let's imagine that we were going to design an interface to install and update the UB editor. It would not be used often, but it would be used by a lot of people. When the user first opens the interface, they don't recognize anything, so they don't know where to start. So first, they spend some time trying to understand what they're supposed to do. After some time, they figure out that this box is for the path to install the engine, which they have to type by hand. Then they try to click on these buttons to finish, but they're disabled and they can't figure out why. Then they realize that these icons represent install packages for artists, developers, or a custom package. They click on the button for the artist package. Now finally they're able to install. So you can see how even though there were only 4 clicks, the time in between each click was long. Here's a different version of the UB editor installer. In this version, the first thing that the user sees is some text to explain exactly what they need to do. They click once to open a file browser, and click again in the file browser to choose a file. They click Next. In this case, the purpose of those 3 icons is much clearer. They click Art to choose the artist's package, and click on Next again. And now they can start the installation, so they click on the Finish button. This required 6 clicks instead of 4, but because it was less confusing, it took less time overall. So because not every click takes the same amount of time, stop counting the number of clicks. Instead, look at how much time is spent in between clicks. The last point is a good way to move on to our final section, motor. So let's look over a few tips focused on the motor system. Once our brain has processed the visual information and decided what to do, the next step is to take action. This is mainly done by the primary motor cortex. It sends signals that eventually travel down the spine to control our motor function, so we can do things like clicking the mouse, typing on the keyboard, and so on. So, number 9, stop using different size and position for similar controls. Instead, use consistent size and position so users can apply muscle memory. What does this mean? Specifically, it means following standard sizes and positions for similar groups of controls that the user clicks on, as opposed to different sizes, which require the user to adjust where they need to click. Now, what does that feel like for the user? Imagine you've spent years learning how to play a musical instrument like a piano. As you get more experienced, your hands start to automatically go to the correct positions, like this C major chord. Now, can you imagine playing the piano for a big audience and the keys of the piano look like this? And to make matters worse, what if the notes on those keys were also different? That's what it can feel like when the size and position of an interface is not consistent. Now that C major chord doesn't sound so good anymore. Another example, the steps on a staircase are almost always the same standard size. Once our bodies have established the muscle memory, we can go up and down stairs very quickly. But have you ever tried to walk up or down a staircase where the steps are not a standard size? You probably don't know the measurement for standard steps, but you do know that it feels different. You might need to walk slower, and if you don't, you could fall. The user interface of your tool is no different. If you have consistent size and position for controls, users can work more quickly once they have established muscle memory for the positions of elements that they click on frequently. But if they try to use that same muscle memory on controls that do not have consistent size and position, they could end up working slower or making mistakes. What can you do about this? First, look at the established standards for size and position for operating systems, like these ones from the Windows Desktop UX Guidelines. Or you can also establish your own guidelines, as long as they are applied consistently across your tool. So what's an example of this problem in the UB editor? In the Assets panel, you can see that the inconsistent size of the menu items makes it difficult for the users to use muscle memory to quickly select assets. So what can we do? Well, we can stop using different size and position for similar controls and use consistent size and position so users can apply muscle memory. In this version, the menu item for each asset is the same size, making it easier for the users to quickly move the mouse to the asset they want. Number 10, stop allowing the user to input bad data by accident. Instead, protect your users from making mistakes by using constraints. What do I mean by that? I mean making it physically impossible for the user to make mistakes. To understand this, let's look at an example from the real world. Imagine that a restaurant wants to stop people from throwing their trays in the garbage by accident. You could have a sign to tell people not to do that. But people might be focusing their central vision on the tray and not see it. Or they might not understand the icons on the sign. Here it's still possible to make a mistake. So what can we do? The most effective solution is to simply make the hole smaller, so it's impossible to throw the tray away by accident. And that's what a number of restaurants do to solve this problem. We can't rely on our eyes or brain to prevent errors 100% of the time. How can you learn from this to prevent the user from making mistakes in your own tools? Well, there are lots of examples from other software, such as Windows Explorer preventing files from being dragged into places where they shouldn't be. Or in Microsoft Office, typing letters by accident in a numeric input box simply sets the value back to its previous value. This behavior exists in a Ubisoft tool for recording and replaying gameplay called Dissect. If you try to update the current time with invalid characters, it simply returns to the previous value. And now let's see how we would fix this within the UB editor. Allowing the user to place assets anywhere they want could quickly lead to problems. Even if it's an accident, the user could make the level impossible to win by covering the flag. So, what can we do? Well, we can stop allowing the users to input bad data by accident, and you can protect your users from making mistakes by using constraints. We can make it physically impossible for the user to put an asset in places that will cause errors, even if it's by accident. This will protect them from making mistakes. So, those are the 10 tips, as well as the human biology behind them, to help you design better tools. I want to finish with one final thought. This presentation was divided into 3 sections: visual, cognitive, and motor. When your users are working with a tool that you designed, first they look at the interface. Then they think about what they need to do. And finally, they do it by clicking on the mouse or typing on the keyboard. But after that, they start right back at the beginning by looking at what changed in the interface. This is the cycle that all users loop through when they are working with your tool. And if you follow these 10 tips, the people who use your tools can be more productive. And when that happens, they can spend less time being frustrated and more time making great games. Thank you very much. If you missed any tips from the presentation, I created a page on my website with a list of all the tips. You can see it at www.davidlightbound.com/10toolstips. And if you're interested in learning more about user experience techniques for game development tools, I wrote a book called Designing the User Experience of Game Development Tools, with more information just like what you learned today. And I will leave both of those on the screen while I take questions. Thank you.